Hello everyone, my name is Anshu and welcome to my channel Bottleneck. This is an Agenti AI cookbook series. In this series, we are going to learn and implement the design patterns for AI applications. In this video, we are going to discuss context cascade pattern. Alright, choosing between a simple script, a deterministic workflow, a traditional RAG system, or a full-blown autonomous agent can be the difference between an elegant solution and an over-engineered, hard-to-maintain mess. To make this choice clear, consider four key factors: input variability, how predictable or open ended the inputs are, reasoning complexity, simple rules versus multi step learning, performance and compliance, latency, determinism, auditability, and any other compliance that the organization or the domain requires. Again, finally, the maintenance effort, the ongoing maintenance cost for that application to be up and running. Now, keeping all these four factors in mind, now it's time to make the choice. The first option is a plain code. The plain code basically has no ML or LLM, and it is best for simple, fully deterministic problems. The inputs and outputs are completely predictable. All logic can be explicitly defined in advance. It delivers the fastest performance with lowest cost. It is easy to test, debug, and certify. It is ideal for strict regulatory or real-time environments. Example could be parsing a structured log with regex, which has couple of fields which are already known or predefined. The next option is workflows or deterministic semi-automated workflows. Best for known processes with clear decision trees. Logic consists of predefined steps and branches. All error cases and retries can be enumerated with workflows. It supports human approval and it is easier to audit and control than any agentic system. It scales better than ad hoc scripts without any AI complexity. Example could be routing invoices by format like JSON, CSV, PDF, XML, and whatnot with validation checks or business logic that is incorporated. All right. Now the third option is traditional chatbot, that is a RAG system. It is best for question answering over knowledge bases. It adds natural language understanding, retrieves relevant document using embeddings. It generates contextual answer but does not take action. No autonomous planning or decision making happens with the RAG. It has lower maintenance and operational complexity than any AI agent. Example could be IT help desk answering FAQs from manual or internal wikis. Finally, we have autonomous agent, agentic AI, best for open-ended, dynamic, and unpredictable problems. It handles unstructured, novel, or highly variable inputs. It performs multi-step reasoning and dynamic planning. It orchestrates tools, APIs, and design logic. It adapts to new situations without predefined branches. It has high complexity and maintenance cost, but it is far more flexible. Example could be customer support agent handling free form emails or dynamic supply chain replanning. All right. Now we have all the information. Pure code is cheap and fast but inflexible. Workflows offer control but breaks down when input grows wildly variable. Traditional chatbots or RAG are great for question answering over documents but cannot orchestrate multi step actions. And AI agents are powerful but demanding, both in terms of cloud compute and engineering effort to monitor, tune, or govern. Before choosing, ask yourself, are my inputs unstructured or unpredictable? Do I need multi step planning that adapts to the intermediate result? Can a document retrieval system suffice for my user information needs, or must the system decide and act autonomously? Will I want the system to improve itself over time with minimal human intervention? And finally, can I tolerate the latency and maintenance burden of a foundation model? All right. Once we make a choice, then we are at the agentic system. These are the principles for building an effective agentic system. The first is scalability. Ensure that agents can handle growing workload and diverse tasks by utilizing distributed architecture. cloud-based infrastructure, and efficient algorithms that support parallel processing and resource optimization. Now, an example could be a customer support agent that processes 10 tickets per minute, may crash or hang when traffic spikes to 1,000 if not backed by auto scaling infrastructure. Next is modularity. Design agents with independent interchangeable components that are connected through clear interfaces. This modular approach simplifies maintenance, promotes flexibility, and facilitates rapid adaptation to new requirements or technologies. Now, an example could be a poorly modular agent that hard codes all its tools in its agent services would require a full redeployment anytime a small addition or modification is needed to a tool. Next is the continuous learning. Equip agents with mechanism to learn from experience such as in-context learning, integrate user feedback to refine agent behavior, and maintain performance relevance as the task evolve. Example could be agents that ignore feedback loops may keep making same mistakes like misclassifying contracts or failing to escalate critical support issues. Resilience. Develop robust resilient architectures capable of gracefully handling errors, security threats, timeouts, and unexpected conditions. Incorporate comprehensive error handling, stringent security measures, and redundancy to ensure reliable and continuous agent operation, and also imply guardrails wherever it is required. Example could be agents without retry or fallback logic may cross crash entirely when a single API call fails, leaving the user waiting and confused. And finally, the future proofing. It is very important that we build a system around open standards and scalable infrastructure, fostering a culture of innovation to quickly adapt to emerging technologies and evolving user expectation. If not, a tightly coupling of your agent to one proprietary vendor's prompt can make switching models painful and limit experimentation. Now, adhering to these principles enables organizations to develop autonomous agents that remain effective and relevant, adapt seamlessly to technologies advancement and changing operational environments. Now, once we have decided and we have an effective agentic system, there are a couple of challenges that we need to see. So, when we are building our first application, the tendency is to put everything into one prompt. Well, there are limitations of a single complex prompt. So, what are those? The first is high cognitive load. Now, the complex prompts bundle multitask, making it harder for the model to allow all instructions accurately. Now, the parts of the prompt may be ignored or under addressed when too many constraints are combined. This results to contextual drift. The model may lose track of the original goal as it moves through different subtasks. Then the error propagation will happen, early mistakes or incorrect analysis, and it will compound and negatively affect the later outputs. Finally, we will also have the context window limitation. Long prompts may exceed poorly or poorly utilize the model's context window, leading to missing or incomplete information, which results in increased hallucination. It is a task complexity as it rises. The chance of generating incorrect or fabricated information increases. Now, how to handle this situation? So, solution to this is context cascade pattern. Well, it can also be called as a prompt chaining pattern or a pipelining pattern. It is a structured approach for solving complex tasks with large language models by breaking a single monolithic problem into a sequence of smaller, focused subtasks instead of relying on one prompt to handle everything. Each step in the chain is addressed with dedicated prompt, and the output from one step becomes input to the next. So as we see, the output of prompt 1 will become input to prompt 2 and so on so forth. It will cascade. This sequential decomposition introduces modularity, improves clarity, and makes the overall process easier to debug, optimize, and reason about. By allowing the model to progressively build on prior outputs, prompt chaining leads to more accurate and controlled results while also enabling the integration of external tools, APIs, or databases at different stages. Now, beyond improving reliability in complex workflow, prompt chaining serves as the foundational technique for building agentic system, supporting multi-step reasoning, planning, decision making in a way that more closely mirrors a structured human problem solving. Now, in the entire scenario, there is one common terminology: context engineering. Context is passed between prompt to prompt and finally it generates the output. So, what is the context engineering? Context engineering is basically the heart of the entire agentic system. Context engineering is the discipline practice for constructing a rich, complete information environment for an AI model before it generates any output. As shown in the diagram, it goes far beyond the prompt wording and encompasses multiple complementary elements like prompt engineering, where clear instructions and role definitions are mentioned. Then we have RAG to inject relevant knowledge or external information. Then we have states and interactions of history to preserve the continuity. We have memory to retain long term and basically the long term knowledge. State will have the short term knowledge, and structured output to ensure clarity and reliability between these steps or the prompts. Together, these components form a unified context that shapes how the model reasons and responds. The central idea is that even the most advanced models underperform without sufficient, well structured context, making the deliberate design and orchestration of the context a primary driver of accuracy, consistency, and system level intelligence rather than model architecture alone. Alright, so this completes the definition for context cascade pattern. We are going to implement the context cascade pattern in our next video using Python with LangChain and LangGraph. And if you find this video interesting, please like and subscribe. I will have the introduction video link as part of the description if you have missed the first video. All right, now see you in the next video. Thank you.